So today, so we're going to talk about the revolutionized data analysis, text-to-SQL and beyond. So my name is Wangda. I'm co-founder and CTO of Y. So we're a startup to focus on text-to-SQL and provide this as API for anybody who wants to integrate this into their stack. So I have a presenter here, Yingjun Wu. He couldn't join. He's a CEO of Rising Wave. It is a streaming SQL company. So I think let's get started. So I think let's go back in time a little bit, right? So to look at the history of the text-to-SQL. So the first, so basically the text-to-SQL is a technology. It exists for a long time, probably for 4 or 5 decades. So the beginning of the text-to-SQL is based on the pattern matching. It's pretty much a rule-based system. It's super rigid. I picked an example system called the precise. So this one, so it's not because it's so it is the earliest one. It's because the name is actually funny. So the name is precise, and you have to only ask very precisely phrased questions. And the second phase of the text-to-SQL, they're based on NLP and deep learning. So basically, this use a lot of sequence-to-sequence model, and also it uses semantic linking to make sure when you generate the SQL query, you can do the predefined join and stuff like that. The example system is called RAT SQL. It's in 2019. So basically, this one is pretty. So overall, this approach is pretty popular before 2021, 2022, something like that. So today we are going to talk about the third approach. It's and this is also the first, the third phase of the technology. It's all based on large language model. You can use in text to generate anything you want, and also it's based on the RAG to basically able to retrieve the relevant information. We're going to deep dive in this part today. So the question here is, is text-to-SQL is a solved problem? I have a question to everybody here. So how many of you tried text-to-SQL? So how many of them implement text-to-SQL in your working environment or product? Yeah, so I think we should talk. So let's try to build a text-to-SQL POC first, right? So basically the requirement is like user want to generate question like, give me top 10 paid customer growth rate month over month. And also you want to make the system can take some updates, right? So you can do some tweak if you have query generated. So as a result, you're going to get a query and generated, so you can take the query to run on your database system, right? So the system is actually pretty simple. If you want to just build a POC, you start with a query generator, and the query generator touch your data warehouse using, so no matter it's a Snowflake or Databricks or whatever database system, and takes this table and schema information, dump this to prompt, and send this prompt to large language model like GPT-4. So with this, you can generate some basic queries, right? So you can probably build this within a day or two. So there are a couple of challenges which I'm going to talk about that. The first challenge is you're going to see the limited context window pretty soon. Basically, you cannot dump all your database context to, no matter the token is 8K, 16K, or 32K window. 20 tables is around 9K tokens, right? So you still have to leave some space for your query generation or chain of thought and some other stuffs, right? So even if you can, so for the recent release of GPT-4 Turbo, it's have 128 KB context window. Anthropic also have 100K, large language model, but you shouldn't. The problem is if you dump more context to the model, the more hallucination will happen, right? So the model performs best when you have the minimum required information here. The more will cause more hallucination or difficulty to retrieve the table, schema, and stuff like that. Also, the cost can be very high. So if you fully utilize the 128K token every query generation, you will cost about $1.5. So if you want to deploy this in your production to let your users to use this to generate charts or query, it's pretty much not sustainable. Also, even if you fully utilize 128K window, you only handle 100 tables. So this is still relatively small for most of the production database. The second challenge is compilation errors, right? So the large language model likes to mix dialect together. So even if you're using GPT-4, the best model, you can still see a lot of issues like data function, JSON handling, missing projections. If you have some CTEs, so you're likely to see some missed projections, and also a lot of hallucinations. So if you ask the model to generate a Snowflake query for you, you probably will end up with getting something mixed of Postgres and MySQL. Also, the more challenging part is non-standard SQL, right? For example, for Snowflake or Oracle or Postgres, there's still a tons of data on the internet for the model to train. But for the other dialects, it's even harder to find this training data. So for example, if you have a streaming SQL, which have a lot of window join, tumble, hop, this kind of stuffs, or if you want to using non-SQL dialect like Mongo, these things can become even worse, and something even basic you cannot get this working. So the third challenge is semantic correctness. So basically, the large language model generates a query based on text meaning from the columns and tables. It don't understand your data. It don't understand your semantics. For example, if you have some table name or column name, it's kind of cryptic, right? Or if you have multiple columns, are trying to so if you have multiple text columns and stuff like that, when you generate the query, you are likely to get the wrong column used. And also, you don't want to get any random result generated from large language model. For example, if you are a data team, you always want to enforce table join, always using some certain join keys. Or if you want to filter some result, you always want to filter, using some specific columns and some specific filtering conditions. So ensure that semantic correctness is important if you want to deploy this in production. The third part is evaluation. You have to make change to your text-to-SQL project, right? So once you have a POC, you want to change your prompt. You want to change the model. If you want to try if the new GPT-4 model works or not. Or if you want to support any new dialect or adding any new rules and instructions. It's very hard to tell if things are working and not working. So we talked to a lot of people building text-to-SQL in their company, and we found most of the people actually stuck on the manual testing and spider testing. So spider, if you are not familiar with that, spider is a popular text-to-SQL benchmark test set. If you can get a very good result on spider, that doesn't mean this can deploy this to your production environment and solve the real-world problems. So how can we solve these problems? The first one is we need to build a RAG layer for the table information retrieval. So I highlight this in the two black boxes here. So basically, you want to retrieve the metadata from the data warehouse, and you want to using this system to be able to find the right table or right schema, right columns, before sending this to large language model to generate query. If you don't do that, and so again, like I mentioned before, you are going to run into some issue like hallucination or missed context and stuff like that. But this part is tricky. So the most straightforward way to build this system is using embedding. You can take all your table schema information. You can take your even column level information. You can embed in individual items, and you can use this to using embedding to match and find the top top 20, top 30, or whatever number to send to large language model. But this approach is not enough. We initially tried this approach, and we say only 56% of the table retrieval are correct. For example, if you have a query, you want to get some information from the date dimension table and stuff like that, and these things are normally not liked by the embedding model. So embedding model will basically throw these tables away instead of adding them to the prompt. So we actually implement our system using a combination of embedding, knowledge graph, and a large language model based. And we see the result is actually pretty good for most of the cases. So the second piece is how we can make sure the compilation is correct. So that's why we added the compiler and the retry logic for the compilation error. So basically, the retry logic is actually very easy to add. If you using for example, if you get the query generated from large language model and you run that against your database system, you probably will see some error and you take the error and ask the GPT to generate this again. This is easy, but the problem for that is there are a couple of problems. One is normally these errors are not very actionable, right? So the error from Snowflake or from Oracle or whatever database system, the error is just saying, there's an error. But it never tells the large language model to say how to fix these issues. So that's one part. And the other part we found is there are a lot of cases the SQL query are directly patchable, right? For example, if you see the UDF function to handle some date, and if you know the date function is from MySQL dialect, but you want to generate Snowflake, you can directly rewrite this query to make that, using the right parameter and the right function to use. And overall, we can patch a lot of queries. For example, the date and time UDFs. We can patch the JSON and flatten unnested kind of queries. And also, if you have multiple CTEs and some CTE in the middle, for that to project some columns, we can also patch that too. So overall, we found this approach is pretty efficient, and also we generate the error message not one at a time. We generate a batch of error message, and we use this to regenerate the query if we have to, if we cannot patch it. So how much help we can get from the compiler, right? So we did some tests. On the left side, it's a spider. We're using the spider as a simple kind of testing to try. And if without any compiler, we got 18.4% of the compilation error. And for the GPT-4 out of box, we can get only 4.5% of the compilation errors. And with our so with the compiler approach I just mentioned, we're able to reduce this to 0.39%, which is 4 queries out of all the 1,000 spider dev set. So after that, so user won't feel too much about compilation errors after these fixes. On the right side, we are using our internal database to do the testing. So we have internal benchmark. We trying to push the complexity to harder. So with GPT-3.5, without compiler, 54% of the queries will directly fail if you give this to database to run. And with GPT-4 out of box, it's 22.8%. And with our compiler, we are able to reduce to 2.8%. So the next part I want to talk about is semantic rules. So basically, we want to make the users can add the semantic rules to their database object, right? For example, they can describe their table, their columns, or how to calculate some specific fields and stuff like that. Or they can also describe when you generate the query, never use any other schema other than the prod schema, right? Something like that. So there are many ways, if you're thinking about this, you can attach a natural language-based instruction to all the level of the object in your database. And this can help you to get the semantically correct queries for most of the time. Yeah, so the other part is we also need to capability to dynamically select the rules based on the context. We also find if you have too many semantic rules, and you just dump all of them to the prompt, you will end up with, the model is really confused about which one to use. And sometimes we'll ignore the rules and stuff like that. So doing some presetting here will be also very helpful. So the last part I want to talk about is evaluation framework. So we are currently open sourcing the framework. We kind of collaborate with Microsoft since beginning of the year. So we call this Atrophish because Atrophish is fast and also accurate when trying to shoot the insect from water. So for this framework, we're able to configure different SQL generation engines, and we also will provide some sample benchmark. Microsoft will also contribute some of the benchmarks. We implement the comparison rule. I think the biggest change in comparing to other evaluation framework is we're trying to make the comparison to reduce as many noises as possible. So previously, if you generate 2 queries and run that, if you directly compare the result set, for most cases, you cannot compare. For example, the column name may be changed, the order may be changed. There are many other things. We're trying to take care of this from the evaluation framework to reduce the noises from the comparison. Yeah, so if we want to go in beyond the standard SQL, we also want to using the same framework or system to generate streaming SQL or generate MongoDB, generate Python data frame operations or plots. So the other part which is interesting is to using the text to SQL to do the query migration. So this is compared to the traditional AST-based, compiler-based migration. The large language model can be really powerful to handle if there's any semantic change between the 2 databases. For example, if the table name or schema name have some slightly change or structure have some minor change, the large language model-based one can handle this pretty well, but the AST couldn't handle this for most cases. And also, we can extend this to performance analysis for your database. I can, do a demo right after this. Okay, we have 10 minutes. Let me try to jump to the demo. Yeah, so let's see which one we want to see first. So basically, this is the UI we have. So we are trying to provide more on the API front. Basically, we can let others to build the API into their product, but the UI is mostly for the demo purposes. So user can choose different databases, or they can also add new database connection to Snowflake or Postgres or MongoDB. And yeah, so we are going to add more databases. So once the database is added, we are going to build a knowledge graph. So if you look at the schema level, we generate these descriptions based on whatever inside the schema. And also we generate the common tables based on the query history, as well as questions you can ask from the database. Yeah, let me zoom in a little bit. So once this is done, so overall this process will take like 1 minute or 2. So once this is done, we can start into asking questions. Let me try to ask the first question. Yeah, so this is kind of like traditional BI questions. So find the customers, compare the 2 year of customer spend and stuff like that. Yeah, let me zoom back. So I just submit this query, and let's see if this is runnable. This currently is running on Snowflake. On the right side, we generate the SQL explanation for the query. So if you are not very familiar with SQL, you can read this explanation to get some understanding of the query. One thing I also want to note is I added some semantic rules about how to calculate the spend in stores, and I specify a formula, sales minus discount times quantity, and as you can see here, we are able to use this semantic rule, and when we generate the query, we use the same rule to generate the query, right? So you can ask some additional questions to update the query. So for example, for this query, yeah, by the way, this query is runnable. I'm not lying. So this query, we are using the absolute difference between the 2001 and 2000. So we can also ask it to change to use the relative increases. So as you can see, we're able to divide the first month to be able to calculate the ratio of the increase. Yeah, so we can also do the reverse generation. Let me copy this first. So if we start a new page and copy this query in, this query is complex. If you don't understand, that's fine. We can regenerate the description. So this query is doing the top selling item for each category based on total sales. This is actually pretty accurate. And also we are able to generate the SQL explanation based on the query you entered, and also we are able to locate which table are used by the query. Yeah, so next one, I want to show you the semantic, the performance analysis. So if you ask the question like this, give me longest running queries in the last 14 days. So this system generated a query for you. You can take it to run. So this currently is running on Snowflake, trying to query the information schema and to get the longest running queries with their ID. So you should finish. Yeah. So we can take the first query. This query runs 300 seconds. We can load the query ID here. And we can see if the system can help us to do the query performance analysis. Yeah, currently it's trying to get the query stats. So this is a query text which run for 300 seconds. And this is a summary of the performance insights. Basically, we take the query stats from Snowflake and we're trying to compress it. And we have our own knowledge base to get the insights from the query stats. So as you can see, this identifies the aggregate operator is the most expensive, so which is this part. And the recommendation saying, hey, you can using CTE or using temp table to reduce recalculate of this operation. So let me show you something. Yeah. So the next one I want to show you is a streaming database. So we connect to us a streaming database running on Rising Wave Cloud, and we can ask the question like this. Basically, this one requires window join. So as you can see, this one, yeah, this one is not using window join. Let me try to regenerate. Yeah, so this one uses a window join using tumble function of the two tables and to generate the tumble and join the two tumbles. Yeah, so let me see what's next. Yeah, so I can show you some notebook operations. So if you ever worked, as a data scientist, you probably have some trouble to getting the data out from your data warehouse. So basically, I put some. Yeah, let me zoom in a little bit. And so so for why we provide the Python SDK, so you can basically install this on the any notebook. So currently, I install this on notebook. So this is already installed. So we can try to import some libraries here and connect to Snowflake instance in the back, right? So the first query we try to generate is get all the cars, a bunch of joins, basically get a denormalized table from the cars database. And this is the query we got, right? So you can directly run this query. If I scroll to the right, you can run this query, and you can convert this to a pandas data frame, and you run it. You can get all the data from Snowflake to your pandas data frame. And after that, you can start to do a bunch of plotting operations. You can ask how many different kinds of cars produced in each continent for each country. You can ask a question like that, and you will get the plot from the plot will be generated by the large language model, and we plot this locally on the notebook. So this is a generated code for plotting. You can copy this if you want, or modify this. Depends on your needs. So we can also do the analysis directly on your CSV file. So this is a CSV file, which is a survey score for people who take airlines. So satisfied or unsatisfied they are to the experiences. So once it's loaded, we can also plot satisfaction for business travel versus personal travel. You can get the plots. And also you can do some other analysis, heat map for correlation matrix for number of features. You can get the correlation matrix. You can understand the cleanness rating over flight distance. Yeah, so you can do all this sort of analysis on your notebook by asking natural language. I have 1 minute left, so let me try to show you the last example. So this is from the command line to do the query migration. So let's first try to find the right database to use. We were going to use this database, and this is a script we need to migrate. So this is a PySpark, which trying to aggregate each weekday's stats from the data, and let's see if we can translate this to Snowflake. So we cat this PySpark file, and we transcode this from PySpark to Snowflake, and this is what we got. Right. So we can be able to understand whatever input script is and convert this to the target dialect. And also we can try to run it, and let's see if we can run this or not. Yeah, I think this is pretty much it. It will take like 10 seconds to run. I will blame Snowflake for this. Yeah, so this is runnable. Yeah, I think that's it. So yeah, I think we are just on time. Yeah, so thank you. So if you want to catch up with me, and feel free to find me, and I will be at the Q&A station later. Yeah, thank you.